Hello, my dear students. Welcome to IKSR chemistry classes. In this video, we are going to discuss soil salinity and its determination. It is a very important and interesting topic under a skill development program, and questions related to it are asked frequently in various examinations of chemistry as well as agricultural science. Let us first of all see what is soil salinity. The soil salinity is the measure of the concentration of soluble salts in the soil. It means greater the concentration of soluble salts in the soil, greater will be the soil salinity. And the most common salt present in the soil is sodium chloride, that is NaCl. However, it must be noted that the bicarbonates, sulfates, and chlorides of calcium, potassium, and magnesium also contribute to the soil salinity, such as calcium bicarbonate, magnesium bicarbonate, magnesium sulfate, calcium chloride, etc. also contribute to the soil salinity in addition to sodium chloride. Some salts are useful also. For example, many fertilizers are in the salt form, such as calcium ammonium nitrate, potassium chloride, potassium sulfate, etc. are chemical fertilizers which are in the form of salt. It may be noted that an important chemical fertilizer, urea, does not belong to the category of salt. It is an organic compound which is not a salt. It is non-electrolyte, but these chemical fertilizers are in the form of salt. It is calcium ammonium nitrate, it is ammonium nitrate, potassium chloride, and it is potassium sulfate. All these are chemical fertilizers which are applied to soil for increasing the fertility of the soil, and these salts are also responsible to increase the soil salinity. Too much salt of any kind, whether fertilizer or not, is detrimental, that is harmful to plants as well as other organisms. These chemical fertilizers are in the form of salt. They contribute to the soil salinity. These chemical fertilizers are useful to increase the production of crops, but too much salt of any kind in the soil is detrimental or harmful to plants and other organisms. Representation of soil salinity. Soil salinity is measured as electrical conductivity. Soil salinity is due to the presence of various types of salts in the soil, and we know that salts are electrical conductor. They are electrolyte. Their aqueous solution conducts electricity, and the soil salinity is measured in terms of electrical conductivity. It means greater the soil salinity, greater will be the electrical conductivity of aqueous extract of the soil. The conductivity of a solution of an electrolyte is given by the following relationship. Kappa is equal to 1 by R into L by A, where kappa is the conductivity of the solution of electrolyte. The other terms involved in this expression are illustrated here. A is the area of electrodes and L is the distance between the electrodes and R is the resistance of solution in between the electrodes. Let us see what is the unit of conductivity, that is kappa. Kappa is equal to 1 by R. The unit of resistance is ohm. The unit of length is meter and the unit of area is meter square. On solving it, we get the unit of kappa as ohm inverse meter inverse, and ohm inverse is also known as Siemens. Thus, the unit of conductivity is Siemens per meter. The SI unit of conductivity is Siemens per meter. But the concentration of salt in the soil is low, and hence the soil salinity is expressed in the units of deci-Siemens per meter, which is abbreviated as DS meter inverse, deci-Siemens per meter. Please note that 1 deci-Siemens per meter is equal to 10 to the power minus 1 Siemens per meter. Deci means 10 to the power minus 1. 1 deci-Siemens per meter is equal to 10 to the power minus 1 Siemens per meter. Now let us see the principle for the determination of soil salinity. But before it, let us see what is conductivity. The conductance due to all the ions present in the unit volume of the solution of an electrolyte is called its conductivity. The conductance due to all the ions present in the unit volume of the solution of an electrolyte is called its conductivity. It is denoted by kappa. It is Greek alphabet. It is not K. It is kappa. The conductivity of the solution of an electrolyte depends upon following factors: number of ions present in the unit volume of the solution. Greater the concentration of salt in the solution, greater will be the number of ions present in the unit volume of the solution, and accordingly greater will be the conductivity of the solution. It means the conductivity of the solution of an electrolyte increases with increase in its concentration. At the same time, conductivity also depends upon ionic mobility. Greater the ionic mobility, greater will be the conductivity, and temperature. As temperature increases, the ions present in the solution move at greater speed. That is, ionic mobility increases and therefore conductivity also increases. The conductivity increases with increase in the number of ions present unit volume of the solution, with increase in the ionic mobility, and at the same time conductivity also increases with increase in temperature of the solution. soil salinity and conductivity of its water extract. When finely divided soil is shaken or stirred with water, the soluble salts present in the soil go to the aqueous medium. When finely divided soil is shaken or stirred with distilled water, the soluble salts present in the soil go to the aqueous medium. The conductivity of this water extract of soil is measured. Then the conductivity of this water extract of the soil is measured. The conductivity of water extract of soil will be directly proportional to the concentration of salt in the solution, that is soil salinity. Greater the concentration of salt in the soil, greater will be soil salinity, and greater will be the concentration of salt in the water extract of the soil, and accordingly greater will be the conductivity of the water extract of soil. In nutshell, we can say that as the soil salinity increases, the conductivity of water extract of soil also increases. Thus, the conductivity of water extract of soil is the measure of soil salinity. Apparatus required for the measurement of soil salinity. This is an auger which is used to take soil sample under the surface, while it is a scaffold which is used to collect soil sample from the surface, and it is conductivity meter. It is a vessel of the conductivity meter. It is electrode. It consists of two electrodes which are dipped into the aqueous solution of the electrolyte, and this digital display shows the conductivity of the solution in millisiemens per centimeter. It is 2.73 millisiemens per centimeter here in this apparatus as shown here. Now the time for self-assessment. Convert 1 millisiemens per centimeter into decisiemens per meter. Here is the solution of this problem. 1 millisiemens per centimeter can be written as 1 millisiemens into 1 per centimeter. 1 millisiemens is equal to 10 to the power minus 3 siemens. Milli means 10 to the power minus 3, and 1 centimeter inverse is equal to 10 to the power 2 meter inverse. Let us see how it comes. 1 centimeter inverse can be written as 1 by 1 centimeter. We know that 1 centimeter is equal to 10 to the power minus 2 meter. Centi means 10 to the power minus 2, and on solving it gives 10 to the power 2 per meter. 1 centimeter inverse is equal to 10 to the power 2 meter inverse. On solving it, we get 10 to the power minus 1 siemens per meter. 10 to the power minus 1 siemens is equal to 10 decisiemens. And on solving it, we get 1 decisiemens per meter. It means 1 millisiemens per centimeter is nothing but 1 decisiemens per meter. It means the reading of the apparatus 2.73 meter millisiemens per centimeter. 2.73 millisiemens per centimeter is nothing but 2.73 decisiemens per meter. And now the procedure for the determination of soil salinity. Surface soil and subsoil, that is soil under the surface, samples are taken from one side of an agricultural field. Surface soil and subsoil samples are taken from any one site of an agricultural field. Three such samples are taken from three different sites of the field, and these samples are mixed and crushed well. The larger gravels are removed. The larger gravels are removed with the help of a sieve, that is chalani, to have a fine mix of the soil. It is the method for collecting soil from the surface. It is crushed into a smaller pieces on a paper, and then this crushed soil is taken in a sieve, that is chalni, and in during this process the larger gravels remain on the sieve while the fine mix of soil goes down in this collector. Thereafter, about 20 gram of fine mix of the soil, 20 gram fine mix of the soil is mixed with 100 ml distilled water in a jar. 100 ml distilled water is added to 20 gram fine mix of soil, and the mixture is stirred well for about 1 hour. This mixture is then allowed to stand undisturbed for 1 hour, and as a result, the heavier soil particles settle down. The salt content of the soil goes to the supernatant liquid. The heavier soil particles settle down. The salt content of the soil goes to this supernatant liquid. Salt soluble in water goes to this supernatant liquid, and the lighter humus, that is organic materials, are present in the soil, comes to the surface of water. Humus comes to the surface of water, heavier salt particles settle down, while the salt content of soil goes to the supernatant liquid. The supernatant liquid containing soluble salts of the soil is filtered to remove humus, and then it is transferred to the vessel of conductivity meter. The electrodes of the conductivity meter are dipped in this liquid, and the conductivity of the solution is noted down. And this conductivity of the solution, that is water extract of the soil, is the measure of soil salinity. Greater will be this conductivity, greater will be the soil salinity. Classification of soil on the basis of salinity. Soils are classified on the basis of texture also. लोम मीन्स दोमट मिट्टी, सैंडी लोम, बलुआही दोमट मिट्टी, and clay means चिकनी मिट्टी. This classification is based on the texture of soil. While soil can also be classified on the basis of salinity, non-saline soil, slightly saline soil, moderately saline soil, and very saline soil. It is obvious that the soil salinity increases from sandy loam to clay. Clay has the highest soil salinity, while sandy loam has the lowest soil salinity. In loam, if the electrical conductivity of water extract is less than 0.17 decisiemens per meter, it is non-saline. In slightly saline loam soil, the electrical conductivity is in the range 0.18 to 0.35, while in moderately saline loam soil, the electrical conductivity is in the range 0.36 to 0.75 decisiemens per meter, while if the electrical conductivity of water extract of a soil is in the range of loam soil is in the range 0.76 to 1.45 decisiemens per meter, it is very saline. The soil salinity increases from sandy loam to clay at the same time as the electrical conductivity of water extract of soil increases, the salinity of soil also increases. Thank you for watching the video with patience. Please like and share it. If you have not subscribed my channel yet, please subscribe it so that you may get information regarding my new videos in time. Thank you again.